In this tutorial, I will introduce you to THELI's data model and the connected hybrid RAM drive storage concept. These are important to understand to get the best performance of the software, and also to understand when THELI uses a FITS file and when it doesn't. I will show you the concept first, as here in this slide, and then later on we will use a practical example for illustration. Let's start with a single raw exposure, a raw FITS file. During processing, different versions of the pixel data are created with fewer and fewer instrumental and environmental signatures. On a machine with lots of memory, all these different versions of the pixel data are kept in memory as long as possible. For example, the current stage, that's referred to level 0, and then you have up to 3 backup levels, L1 to L3, which keep the older processing stages. When you add another step on top of level 0, then the data in level 0 get pushed down to level 1, the data in level 1 get pushed down to level 2, and so on. And whatever is kept in level 3 will be discarded. Like this, the input-output on your drive is minimized and the performance, the speed is maximized. Of course, in the software, there's a setting that allows you to store FITS files for each of these stages if you want to. I will show you that in the practical demonstration. Now let's have a look what happens on a machine that has less memory. There, it may not be possible to keep all the level 0 processing stage in memory. In this case, FITS files are written to drive as necessary. It is possible that some exposures are then kept in memory only and others are kept in FITS files only. So when you look at the files in your data directory, you might encounter what you think is an incomplete set of FITS files. This is just because all the rest is still kept in memory. There is also another situation. Some processes THELI uses, for example, for coaddition, it uses SWARP, or for object detection, it can use SourceExtractor. In these cases, these external programs, they need FITS files to run. And therefore, you can have both a memory copy of the data as well as a copy in FITS file. THELI will always try to access the data in memory before it accesses a FITS file. It is very important to note that THELI owns all the FITS files it creates. Internally, it maintains links to these files because it can move them around to different backup directories, or if you flag an exposure as bad, this FITS file gets moved to a different directory. So therefore, you should never manually tamper with the FITS files while the software is running. It is okay to look at them using your favorite FITS browser, FITS viewer, for example, SkyCat or DS9, but you should never move or delete these files manually while the software is running. This is because it could be the only location where the current processing stage is found. And then if you move or delete the file, you take it away from the software, and then most likely the processing will crash. Now let's look at how much memory is needed. In general, THELI is fairly humble and dynamic in this. For example, you could easily process a 10 gigabyte raw data set on a machine that only has 1 gigabyte of RAM or even less. This depends a little bit on the file size of the individual exposures and also the number of CPUs that you're using. If you use a lot of CPUs, then of course your memory, the memory requirement is larger. As a baseline, I would think that if you have twice the amount of memory, then the storage footprint in terms of 32-bit FITS files, then you will have very convenient and fast processing. In principle, THELI will take as much memory as it can get, but should you encounter a situation where your computer starts swapping, then you can minimize the RAM usage in the user interface which forces THELI to write a lot more FITS files. And in addition, you can also reduce the number of CPUs you're using in parallel. Now, let's see how this works in practice and how much control we have over this. Let me draw your attention to the settings here in the upper left. With the first pull-down menu, you can choose whether temporary data are always written to FITS files or only if necessary. If you're using a solid-state drive, then this slowdown will hardly be noticeable if you use the always setting. With magnetic disk, however, the overall processing time could then become dominated by the input and output on your drive. I recommend that you use always if you are new to the software, if you have a rather difficult data set that requires repeated processing, or if you need a record of all the processing stages. If you are experienced or very familiar with the data from a particular instrument, then intermediate data should only be stored if necessary, as it is right now. Next, here under Parallelization, you can set the number of CPUs or threads you want to use. I recommend that you use the maximum number available, which is the default setting. Like on my machine, this is 8 threads. I cannot select more than 8 threads at the same time. This doesn't mean that all CPUs will be used all the time, because parallelization is very problem specific. It depends on the number of detectors in your instrument and on the specific task at hand. At the same time, it is limited by the thread safety of a specific library, the compilers used, and the memory requirements of a specific task. In the future, I might also support parallelization on a GPU. That, however, is very problem specific and currently much more restricted than parallelization by CPUs. And lastly, down here under memory usage, you have some control over how much RAM THELI is used during processing. You should make changes here only if your machine starts swapping. When you select minimize memory usage, then every time an image is processed, a FITS file is written and the memory is freed immediately. You can also see that when I click here, look at what happens in the pull-down menu up there. This is then set to always, and you cannot change this anymore. For the next processing step, the image then needs to be loaded again from the FITS file, and obviously this makes processing very slow. But in this manner, you can process very large data sets with very little memory by clicking this checkbox here. The setting above, maximum usable memory, this is a very soft limit. The default setting is the full amount of memory available on your machine. And the goal here is that FITS files are written sooner and more memory freed is sooner than normal. However, your operating system is in ultimate control of your computer's memory, and at this level, software developers have fairly limited options. Therefore, it is not unusual that the threshold you set here would be overshot by 50% and perhaps much more than that for reasons that are untold. So should you consider reducing this number, I recommend you reduce it at least by a factor of 2 or 3, and at the same time also use the number of CPUs at the same time.